Everyone, welcome. This is the Converged Edge Center of Excellence panel. We're looking under the hood in edge solutions in practice, so I'm really excited about this panel. We're going to dive right into it here right away. The panelists here are an excellent brain trust of learned professionals and have a lot of hands-on experience with edge. Unfortunately, we did have Zachary, who was not able to join us here in person today. But fortunately, we got a chance to catch up with Zach, and we asked him, security is an issue, and it's top of mind for everyone. Who do you see, and what do you see as the biggest security issue in IoT? And Zachary had this to say.
To me, the biggest security issue in IoT today is the substantial increase in the risk of a cybersecurity event over the past decade. This increased risk, I think, is mainly caused by two forces working together: the sheer growth of data and connected devices, and the digital immaturity of the people and their processes pushing these connected devices into industry. For example, in 2019, according to IoT Analytics, there were 10 billion active IoT connections globally. This number is expected to increase to more than 22 billion by the end of next year. That's a CAGR of 12%, which is incredibly large. And then just to think about the people running behind the processes there, COVID really pushed us in 2020 to start connecting more devices and having IIoT available in every market. And you think about the processes that are running these companies, unless your company was put together in the last 5 years, you're probably running through practices that are IoT industry 3.0 type of processes. So to me, those two factors working together, you have an increase in the sheer volume, the amount of data being shared, and the immaturity of the people behind the scenes and the processes behind the scenes that are supposed to be protecting these. For example, you have a password on a connected device set as admin password. That should not be the way it is. That should be printed on the device. It should be randomly generated. And to me, that's really the biggest factor. Is the risk of these happening is now increased because these two factors.
Excellent information from Zach. We appreciate him
to mitigate
joining us here with the pre-recorded message. We also had an opportunity to follow up with him, and we also asked him how should products be designed from a security perspective to mitigate all those potential risks.
To mitigate security risks, products should be designed with a strong focus on security. You can do this by following guidelines of standards like IEC 62443, which is an industrial standard for applications, and it defines the necessary security processes and functional measures for device manufacturers, system integrators, and operators. And it breaks it into those three key roles because each key role is responsible for something different. And from the manufacturing side, it's important to notice and to use these standards from a development standpoint to make sure that you're keeping security in the front of mind. The security mechanisms and processes that must be implemented have to be at all three roles, and it's rather than a single actor, which makes it much nicer. But if everybody's following that same standard, you can then implement the security measures needed at the manufacturing side that will eventually get there to the operator or owner side. The other important piece is to understand how cybersecurity requirements are changing globally. So in the next few years, the EU is going to be passing a Cyber Resiliency Act, which requires cybersecurity measures to be taken in order to achieve CE marking. And what that means for manufacturers is that in order to get CE marking on a product or so that it's able to be sold in the European Union, you'll need to follow certain cyber resilience and cyber security measures. These are still being defined, and for the most part, you can go read about that act online. But in general, it means that you're going to have to do cybersecurity in some way or fashion for any connected device in order for it to be sold within the EU in the next 2 to 3 years. So that compliance is very important when it comes to designing product, but ultimately, compliance has to start now, again, with the digital maturity of your systems. Are my people understanding what needs to happen? Is the processes in place behind the scenes that I can even accept a cybersecure device. So to me, that is the most important step, is creating a more mature and compliant cybersecure workforce so that they know what's going to happen in the future, so that you can implement new cybersecure products into your platforms.
Fantastic insights from Zach. We appreciate his participation. I want to throw things over to Jeff. Jeff, if you were to give advice on hardware selection at the edge for someone deploying an edge solution, what would that advice be?
I think it was brought up in the last panel. I think you have to think ahead. You've got to future-proof. So a lot of people, when they're trying to solve an application issue, they're thinking about, how do I solve this problem? But if this is going in as infrastructure, it's not only this problem, but the other problems that you want to solve with the same hardware. The cost of implementing and deploying hardware sometimes is more than the hardware itself. And I think that's where sometimes people forget. They don't think about that. So they're concentrating on the cost of the hardware. And if they get the hardware wrong, this could cost 2 or 3x if you have to rip and replace, or you have to upgrade because now you have another application and you can't run it on the platform that you provided. So I would say that's the big thing, is take a step back, not only focus on the application you're trying to solve, but think about what other things you might want to do with that hardware, and make sure that you create a platform that can be used for other things, and you have some headroom to be able to upgrade into different applications, or as your application grows, you can leverage that same infrastructure.
Perfect. Yeah, and I know that, Guy, yesterday you spoke about energy during your keynote. Today, this morning, you spoke on the industrial IoT side of things. What are some of the unique challenges that edge deployments face in transportation in that industry vertical?
Yeah, and transportation is very, very unique. And what I'm going to put with what makes transportation unique is really the mobility aspect of it. And that's number one. And number two, the environment. And they go hand in hand. Let me give you a few examples. A number of years ago, I had the opportunity, the FAA and some of the airline carriers, it was considered start allowing us to make cellular phone calls on the plane. Excuse me, while we're flying. Well, now the systems that we had to make phone calls, we've always assumed you're traveling in a car. We never assumed your phone is going to be in a platform going 600 miles an hour. And if you've ever worked in the wireless space, the timing tolerances and the protocols are incredibly precise. We literally manage picoseconds and nanoseconds. May not feel that way, but the level of precision and accuracy required is phenomenal. So the type of edge computing to gather the phone information to think about on the plane, that you're going to make a call, and you're on a platform going 600 miles an hour, and now think how fast the handoffs are going to happen to the cell towers on the ground. The system wasn't designed to do that. So we had to go back to some fundamental research on the edge side, the edge in this case being a mobile platform called a 600 mile an hour plane. That created a unique challenge. And by the way, all of these, like I said, they're all about the environment. Another example is AMRs, autonomous mobility robots, that you may see in a factory. And those inside, there is an edge computer. It's got sensors inside, it's got tasking, it's moving around, but it operates in a unique environment where obviously there's a lot of different objects that it has to understand, but it also has to receive instructions of what to do and where to go. And inside a lot of these facilities, it's really hard to maintain connectivity because you got racks and rows of equipment, and sometimes you have many Faraday cages, which essentially means I'm blocking all the signals. So not only do I have to take into account the edge computer itself, I got to take into account the wireless transmission capabilities. How am I doing that? Another one would be mining. So in the world of mining, we do a lot of work to monitor telemetry on where the trucks are going to move and to optimize their routes. And the reason we do that, we actually design solutions for the mining industry in that route optimization, is to minimize wear and tear on a tire. And a tire on a dump truck, and those very large ones, they can cost $250,000. So That's a unique environment but what's different about that? The latency, how fast I got to do something, is much, much different. And so we can reduce the edge computing costs. I don't have to be computationally heavy. And I have to get the right amount in that edge computer based upon that specific use case in that environment. And then lastly, just the last one I'll give, because kind of show you the gamut that we got to deal with in the extremes when we think about IoT and edge computing, is on the moon. So we are now designing and building lunar probes that go and search for ice on the moon. And why do we want to do that? Because if I can find ice on the moon, I can split that, I can get hydrogen for fuel, I get oxygen to breathe, and if I melt it, I can drink it, it's water. And that means that we don't have to haul that up there. But now think about the environment again. Now I have an edge computer that has to withstand dramatic swings in temperature. Very hot, very cold. I have to manage it against, if it's on the surface, massive doses of solar radiation hitting it. And so, then you have to worry about something like that. You have to put AI in there because you have to operate autonomously as much as possible. Why? Because I can't always guarantee satellite coverage to talk and relay signals back to the Earth. So these are like 4 kind of, and I didn't even talk about cars. And that brings a whole nother set of animals in. But I just want to give you guys a peppering. There's really a lot of extreme environments that put intense challenges on our edge computing devices today.
Yeah, that's a fantastic array of examples and use cases that Guy highlighted. I'd like to talk with Jeff again. So which hardware features do you feel are critical, in the transportation industry when we're looking at use cases, and what do you most commonly see as a feature set?
Well, I think one of the things that people across the applications that Guy just talked about, one of the things that people don't think about is the reliability that you need to withstand those kind of applications. So if you're in a vehicle, like a piece of mining equipment, which we service that industry, I mean, there's a lot of shock and vibration that goes day in and day out. The harmonics that your hardware is withstanding day in and day out, you have to be able to withstand that over years of service. So I think that's probably one of the key things. You have to look for something that's designed for that rugged ability. The other thing in transportation is if you look at like buses or, again, equipment, the temperature ranges that they have to withstand. So you've got to have, and Guy mentioned this, across that temperature, temperature spectrum. But when you're in really cold environments, like for buses, for instance, the voltage of a battery is essentially, could be, a 12-volt battery could be 8 volts when it's negative degrees. So your product, your hardware, has to be able to power up at those low voltages. So you've got to make sure that the product you're designing or the infrastructure you have can handle those. It's not just the application itself, but it's really the environment. So I think that's one of the big keys.
Just jumping on Jeff's comments there, that my team I always have a tendency to simplify things so we can understand it. And I always talk about the goes-intas and the goes-outas of our systems. And you think about what Jeff was saying, the goes-intas of that power, that is so, and I'm glad you said that because people miss that. Mm-hmm. And it's like, hey, I need, this CPU, this edge computer needs solid 14 volts to operate. If I don't get 14, it's going to reset. And it's going to continuously reset. So now you have to design for that goes into powers to compensate for that. And that's, those environments make it tough.
Yeah, that creates a down situation, and then a piece of mining equipment, you can imagine what the downtime of something like that would cost.
So we launched into orbit, we went lunar. I wanted to get Eric's thoughts and opinions on what are some of your favorite real-world applications for edge, and what does that look like when we look and look under the hood?
Yeah, so one, I'll comment, we're the software guys, so I love when you're talking about hardware, flexibility is key. So being able to deploy software on multiple types of physical devices depending on the environment, depending on the use case. We do stuff in rail, we do stuff in automotive, we do stuff in oil and gas, right? And typically it's our customers that say, this is what type of device you need. So as far as use case, I love AI at the edge. So we've got a customer in oil and gas, the oil and gas technology company. We are not oil and gas experts. We're software experts. But they've been doing AI for 30 plus years, right? They're experts in how you drill for oil. And this AI is built in multiple different types of technologies, right? But all running in the cloud. And the use case here was, well, we've got a customer in Saudi Arabia that, I can't stream enough data from that well site across satellite to our data center. It's just, I can't use all that data. So their AI models, while very sophisticated, are only using a portion of that data. And also the use case is my customer doesn't want that data leaving the kingdom. So we need to use edge computing and find a way to move these massive AI models to the edge. And so the use case, they came to us and said, hey, look, we've got these 38 models. Some of them are 30 years old. But ClearBlade, can you run these at the edge? And of course, my sales team said, sure. And the engineering team said, what? And yet there's some open standards, right? So we didn't just come up with this on our own. There's an open standard called ONNX that's supported by Microsoft and others, where we said, okay, let's build that into our runtime, and let's test these models. And over a few months, we were able to show this customer we can run every one of these 38 models in whatever technology you used, but you exported it in this format at the edge. And so to me, that use case is great. We're not the oil and gas experts. I'm not the hardware expert, but we did our part of the solution and allowed us to win a great deal of business against some of the biggest edge companies out there, because we could show that we could execute there. And I'm like, wow, this is pretty amazing. So that's a use case that I'm real excited about. And I see, by the way, AI being the killer app for edge as we move forward.
Yeah. Wonderful insight, because data, and Eric referencing data, is a really important facet when we're talking about edge, where that marriage and where that connection between the physical world and the digital world is kind of converged, is coming together. Sanjeev, I know when deploying AI at the edge, like Eric was just referencing, what considerations should customers be making, and how high data flows and all that information coming from the edge goes up into the cloud?
Yeah, that's a great point and question, as my colleagues had highlighted here as well, because there's a lot of value of AI at the edge to be able to provide those insights, immediately to people, to machines available. But then there's also the aspect of maybe you want to aggregate that information in the cloud to serve other use cases and business objectives, because you might need information from other assets to paint a bigger picture of something you're looking at. And so I think there's multiple considerations when you're trying to move data from the edge to the cloud, right? I think the first piece, not even talking about the volume of data or the intensity, is around that security and privacy of that data that you're sharing. You talk about, the kingdom in Saudi may not want that data to leave. They might be okay with certain aspects of it. But when you think about the sensitivity of the data that you're producing, right, whether it's medical images, it could be personal identifiable information, you have to have strict security policies in place. Even if it's as simple as company operations, if it's the mining, right, that could give insight to competitors, what you're extracting or how well you're performing. So I think the security aspect in terms of getting the data from the edge to the cloud, have those right protocols in place. But not only that, then making sure the data is going in the right place, you have the right access controls there to make sure people are only accessing the data they need. And I think, when we think about what Zachary was talking about, compliance, regulations, right, I think that's going to come up more and more in the near future, as we see in Europe and other states and so forth, because if your applications are running in the edge in these different locations, then you have to be able to adhere to all those regulations and so forth. So I think security and compliance and privacy has got to be top of mind. The second would be around that, the data management and bandwidth, right? I like the mining example. We hear examples of dense data sets, right? I think computer vision, video comes top of mind, but there's only so much the infrastructure can support in offloading that data back into the clouds. And then you get in the question, one, what is it that I really need to serve my use cases? You're not going to be able to send all your data at once for purposes, right? As I like the Faraday cage example, right? Because you might be inhibited. And then there's real bandwidth constraints, right? I know that's great. I think nowadays with Starlink, you have more access to high-speed internet, but even then there could be capacity requirements that you're not able to meet. So I think it's really to be cognizant of how much data you're trying to move. And then that third piece is around the latency. So even if you're moving that data, what are you trying to solve from a business use case perspective? And trying to understand, so I think of utilities, right? Like if I'm looking at multiple meter substations and I'm trying to determine outage responses, what do I need to do? And I could have Edge AI provide me the like low-level insights, but if I'm looking at it from a holistic picture, then do I have all the information from all those assets to make an informed decision? I think that gets into understanding how soon the data comes in, having insights to what data is available and not available when you think about connectivity, to know that's there. And if you're serving business critical processes, then you might need to have redundancy in your network. And the last but not least, right, is just understanding the cost, right? Like there is cost to move that data from edge to cloud. It could be the volume of data. It could be your internet service providers. Once it lands in the cloud, right, then, storing it, accessing it, managing it over time, the privacies. So there's a lot of things to consider, right, when you think about that movement of data from edge to cloud. And really it's just making cognizant decisions of which analytics or, applications you're running for what purposes, and making sure you're making the right decisions there.
Terrific. Yeah, really good information there. And I think that that's a call out to how global deployments have those variables, right? So we talked about a solution going into, Saudi Arabia and the UAE, and Zachary did a terrific job of outlining those, coming requirements and those facets that are applying to the EU, and we have security and compliance and regulation here stateside that all needs to be considered and is something that's really important when we're talking about deploying edge solutions. So what I really wanted to kind of get our arms around for examples in the real world, and I wanted to ask Guy this first. I wanted to ask, could you share an example of where an edge solution helped in safety?
I got two, and it was the Faraday cage. I said Faraday cage, and you made me think of another one. I'm going to give you two, and it was kind of more related to my first question. In the automotive space, we helped develop if you guys recall or may be aware, when a car has an accident, it can auto dial out and help you, right, for an emergency. And so when we were doing all the initial testing of this, and everything worked, except we didn't crash the cars. Oh. Now, the reason that was important, Jeff was talking about the shock and vibe. Well, there's a lot difference if a car's doing 100 miles an hour and when it hits something, a barrier. And typically, the Insurance Institute crash testing, you don't do those speeds. But in the real world, people do. And so we had that awe blank moment when we realized this, because when you did a car at 100 miles an hour, the edge computer came apart. Yeah. And the metal wrapped around the antenna and created a Faraday cage. And we're like, it didn't help. So that was an example why you got to test, right?
Probably wasn't an Advantech computer.
It was not an Advantech computer.
All right, just for the record.
I think I built it in my garage, but that's a whole other story. But the one I did want to share with is really around worker safety. And I talked a little bit yesterday about it, but this is a solution that with our great partners at SAS, we've collaborated together and put a solution that it actually has to orchestrate between the edge, and Sanjeev was actually talking about it, orchestrating between what's happening on-prem in an edge computer and what's in a cloud. They have to work in concert together. And so in this worker safety solution we jointly developed, that it has the ability to tap into the cameras in a factory or a warehouse, and we can monitor unsafe behaviors. And so for the first time, and you have to do, and if it's dangerous, latency comes into play. So if the speed matters, you need that edge, right? Speed doesn't matter, well, I can process more back in the computer, or back in the cloud side, and we gotta modulate that. But the good it does, for the first time with solutions like this, most companies don't go look at the video until after the accident. And they go, yep, we had an accident. But what they don't know, that person that got injured, they probably did that unsafe behavior 100 times. Yeah. Just didn't get caught, literally caught. Now, this solution, and we can do it right on the edge, now we can look at that and we can catch near misses. Now if I got near misses before an accident happens, now we can course correct the daily safety meetings, and we can actually, because what happens, the way the system works, more near misses, your risk score goes up, 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 up. And what are we doing? We're predicting the future. We're now predicting you're going to have an accident. And now, with these types of solutions, you got to think about the responsibility of the company. Hey, I'm seeing this go up. What actions are you taking to keep your people safe? And so if you take proactive action, we course correct it, and we see a reduction in the unsafe behavior, we change the future. Now we can see significant reduction on on-prem injuries, and even to a degree, some of our clients have even renegotiated their workers' compensation rates because they have this technology to help them. So, I mean, that's an example I can give you where, edge computing literally saves lives in this particular case.
You just justified why I pulled that snapshot out of my sports car and threw it up.
Get that out of here.
Keep my insurance rates right where I need them.
This is why we're here. Those are
Needed predictability.
real world examples.
Yep.
Absolutely. Yeah, and I know
I was
that.
going to say, if it's okay to hop on, I think what Guy said is very important. I think the interesting piece around worker safety, especially if it's new to organizations, is that I like the theme. I think it's come out a couple times. The whole crawl, walk, run, right?
Yeah.
It's like they want to use existing infrastructure, existing investments. They've shared with us that it needs to be cost effective, right? To be able to say, hey, we can put this in. I mean, you may not be able to capture everything 100% today, but show where you have blind spots, figure out where you need to invest in either new cameras, new sensing technology, and other pieces, because it could be a vision-based system and other aspects. I think that's a very important piece there just to get up and running. And I think what Guy said is about just having that visibility insights to not only what's happening in real time, but what's happening in the past week, month, et cetera, across facilities, because the goal is to change that worker safety culture. I mean, yeah, we would like to prevent these from happening, but at the same time, it's like, how do we give the tools and insights to those facility operations managers, whoever are doing those activities, to be effective.
And guys, I'm going to give a shout out to Sanjeev. You guys want to meet a rock star? This is it. I mean, he is phenomenal to work with, and I'm so privileged to have the opportunity to work with him. But I've seen him in motion, I've seen him in action, and his insights, and when he speaks, I listen every time. It's like I learned so much. So Sanjeev, thank you.
I appreciate it.
Brilliant.
Perfect. So I know that one of the hottest topics in Edge centers around interoperability and compatibility. So with the marketplace having so many different vendors supplying hardware, edge solutions, edge-only devices, things that are half-baked, fully baked, I'm really interested to hear, Eric, I know we've talked about this previously, but what some of your thoughts are on that compatibility or interoperability.
So I have opinions. And I'm going to call it the F word, flexibility. And my opinions are that the separation of hardware and software should remain separate. I think hardware people should do hardware, and software people should do software. And having that flexibility of being able to marry an Advantech and a ClearBlade, right, to solve a solution, and a ClearBlade at Advantech and a Phoenix Contact, right? And because of the diversity of all the solutions that Guy's company has to put together, right? You need that flexibility to say, okay, play your role. And if you look at history, look, hardware companies do hardware really well, but they haven't necessarily been the best at software, all right? So having that ecosystem of partners that work together and they do their thing the best. We focus on edge computing and IoT. We do not focus on analytics and AI, so that's why we partner with SaaS and stream that data into SaaS and then get the resulting models back. I mean, I think Steve, I saw Steve Enk in the crowd. Thank you, Steve, for your integration work with ClearBlade and SaaS. So the future of I see Edge as trailing IoT a bit in the last few years. IoT's first, and Edge is just starting to get going. There's been a lot of talk about Edge, but I think it's been not as much action, and now you're seeing more action because people are realizing the value of running that AI model on the machine, next to the machine, in country, keeping that data private, and streaming terabytes of data very cost effectively as opposed to trying to ship it over long distances into the cloud, right? So this AI revolution is powering the edge movement now, right? So at the end of the day, you've got to have best of breed vendors that are doing things like making edge really hum, as opposed to just moving containers around. I see a lot of, I mean, I've got opinions on that too. It's not that it's not valuable, but I see a lot of vendors screaming about container movement. I'm like, I think that's a tangential problem to actually having a runtime at the edge that's flexible and collaborates with others. So I see the industry going that way. I think you see IoT kind of weeding out on the software side. I think you'll see the same with edge. Yeah. And then you'll start to get to some really valuable use cases that are real meaty as opposed to more fluffy.
Sorry, Sanjeev.
No, go ahead.
I was going to just jump on that a little bit about when you think about the edge computing, and particularly if it's in a life, a critical, mission critical type scenario, and if you're totally relying on the back office or the cloud, you got to have resiliency, right? And you want enough capability in that edge computer if that link is severed, that operations runs, right? Yeah. And I always say, you guys know I do a lot with the manufacturing, and there is no plant manager that would survive their career if they kept going and tell the CEO, well, we couldn't produce today because the cloud went down. Yep. That's a very bad scenario, and that will not happen. And so you have to design this resiliency of island. It doesn't have to run forever, because eventually you do run out of parts, or something, but you got to have that resiliency on the edge, and you have to design in that bad case or that worst case scenario.
Yeah. Run completely disconnected, possibly run forever, because you basically know what to do when your data fills up. You have rules for that. We deal with use cases like this in rail, where you have a crossing that's in the middle of absolutely nowhere. It's got zero connectivity, but they need all that data to be logged, right? Mm-hmm. And then eventually a collector comes by and sweeps up that data. But you nailed it. That resiliency piece and run completely disconnected is critical. Yeah.
And I was also going to add, if we had like key words, I was thinking battle tested, right? Yeah. I think the key thing, and what we bring from SaaS and others I see as well, right? Like, because we're not focused on just one use case or one item, right? We're really focused on building capabilities that can solve multiple challenges, right? And being able to extend to those future-proofing items that you may not consider and so forth. And just being really able to run in a production sense with the resiliency, with the scalability to run across thousands of devices to handle the configuration and so forth. So there's a really important piece to that, because I think that comes with credibility, right, versus something that may have just come new into the marketplace, but how sustainable, maintainable could it be? It's those other things that you don't think about until things don't work well, and then there's finger pointing and such, right? And people are trying to scramble to figure out what to do next.
Jeff, what have you seen with all of your experience in, which industries have been most transformed or have the potential to be the most transformed by Edge?
Again, I think I heard it this morning. Almost all of them. Advantech crosses into every single industry out there. We're starting to become more vertical focused because there's so many verticals that need things that are very specific to that industry. The one area that my team sees probably the biggest growth potential is utility market. Energy in general, I think, because of a lot of the infrastructure is pretty archaic. And so there's just a lot of opportunity for using edge computing and edge AI to enhance. The issue right now is security. So I think, again, it brought up this morning, things are disconnected, so that means more secure, but it also really limits the capability and the functionality and taking advantage of virtualization that could really transform the industry. So Advantech's working very closely with Intel on virtual protection, which is very hardcore relay right now. And it's a long, long journey, but we see a tremendous amount of upside and potential for compute technology, not only edge, but also server technology at the edge to really transform that industry. So if I look at energy across, oil and gas is a little bit different, but specifically in renewables, managing the grid is going to be critical. You have more and more power, with the explosion of population. Renewables is going to be more and more important to be able to manage that in real time and not allowing, letting the edge compute decide how you offload the grid and use renewables at the right time for the best cost savings. I think that whole energy sector for us is the most exciting right now.
Did everyone in the crowd and did everyone online see Guy's eyes light up when he said energy? Immediately. It was a great keynote yesterday.
He slipped me a 20 before. I'm not going to lie. There might have been a few little cash exchange.
To add to what Jeff said, when I look across our customer base and I try to see trends, it's energy. You nailed it.
Yeah.
Because it's like it's either energy savings or it's how do I log my commitment to carbon neutral and make sure that my buildings are more efficient, right? My transportation's more efficient. So I'm starting to see a trend, and okay, all of these somehow have something to do with energy and conservation.
Yeah.
Awesome. We are close to the top of our time here. I did want to squeeze in one last question to all the panelists. So very quickly, with the 2 minutes that we have left, please, each of you, summon the crystal ball and talk to us or tell us a short sentence about what the future is for Edge. I'll start with you,
all right.
Eric.
Taylor Swift at the edge. AI. I mean, I said it earlier. AI is the killer app for Edge. What we've been doing before has been protocol translation, I think lightweight Edge. I think AI at the edge is going to show extreme value, and that's what I'm seeing our customers gravitate towards. Now they're saying, oh, we're more interested in what you're doing at the edge.
Guy.
Yeah, so in the world of manufacturing, I think of it that way. I think about the 10-year journey that our factories are on to get into a world of hyper-automation. So if I think about the future of Edge, it's really about incorporating this whole concept of self-healing factories. And it's going to be instrumental to do that. And so Eric was talking about flexibility. Jeff talked a little bit about adaptability. That is going to be needed because eventually the factories of the future have to keep running and in bad scenarios. There's storms, weather, I can't get to the cloud. So this intelligence to operate these factories and to self-heal them is going to become a bigger and bigger part. So that's kind of where I see the intelligence, and AI is absolutely a critical component of that, is going to be where a real key for manufacturers.
You're never wrong if you say Taylor Swift and AI. That's a go-to.
I'm going to jump on Eric's bandwagon with AI. If you look at just from a pure hardware standpoint, the advancements that are being made, the investments companies like NVIDIA are doing with their Jetson platform, moving GPU technology to lower and lower power, but more and more capabilities. And there's multiple companies that are also vying for that NVIDIA space. So I think you're really starting to get a power envelope and a performance capability that's very cost effective to be able to do more and more AI capabilities at the edge. So I think that's definitely going to be something that's just going to continue to grow. As semiconductor processes get more efficient and you can really keep shrinking the dies and shrinking that power envelope, it's just going to keep getting better and better.
By the way, I'll add, Super Bowl, 20, 30 years, we're going to laugh that we even used a thing called a cloud. I'll guarantee you that. Of course, I'll be gone by then. But it'll just be ubiquitous computing.
Sanjeev.
We're heading that way.
So, I mean, I think just adding on, I think what Guy said around the hyper-automation, when you think about manufacturing, industrial operations, and so forth being disconnected, I think in other panelists that we've heard earlier today, like from a use case perspective, I think there's challenges with even the workforce, right? Like the talent that's coming in. So I would look at more AI, not just to solve traditional, challenges, but that evolving use case to understand how do we help like workers of various skill forces, right, coming through? How do you help them make better decisions using new information sensors such as video, vision-based to do worker safety? Just provide a more holistic, operations focus and enhancing the overall capabilities of these facilities and so forth, just to make it as the next gen factory and so forth. So I think it's just unlocking all those new use cases, right? Especially to Jeff's point, as it becomes cost effective to move some of these Gen AI, CV, other types of analytics there closer to the edge to make it more personalized, so you don't have to worry about that security, compliance, other things leaving and so forth. I think that's going to be the emerging trend into edge coming in the near future.
We went 2 minutes over. I hope everyone in the audience here thought that was worth it. Everyone online, I want to take a moment to thank IoT Community, our hosts, SAS, for putting on such an amazing event here at their venue. I want to thank all of the panelists, the Brain Trust here. Please join me in thanking them for their thoughts today.
Thanks, Cole.
Thank you.
Thank you.
Cole.